In this video, we will be seeing about chopper and DC-DC converter. So we will see about the control techniques, step down chopper and step up chopper. What is a DC-DC converter? Basically, they are power electronic converters which will convert fixed DC voltage to a variable DC voltage. So if I give a fixed DC input like this, I may get a variable output. That is, the magnitude of this has been changed. That is, if I give 100 volt, I can get 50 volt or I can get 200 volts also. So it can either step up or step down the voltage. So this can be considered as a equivalent of a transformer. So we know what an AC transformer will do. It can step up or step down the voltage. Similarly, DC transformer or this DC-DC converter functions like a transformer, but the input and output both are DC. Let us see the applications of DC-DC converter. So, if you take this computer CPU, you have many components connected to it. So, each device may require different voltages, and you have ICs which may require different voltage. You might have seen these type of connectors in most of the electronic components. 3.3 volt, 5 volt, 12 volt, 15 volt, because each IC or each equipment may require different voltage levels. So this DC-DC converter can be used to achieve the different voltage levels. We will give a AC supply to the CPU which has a inbuilt rectifier which converts to DC. That DC input will be given to this DC-DC converter. From that you can obtain the required voltage. Looking into the renewable energy system, which consists of two energy sources, solar and wind. This solar will give you the DC output which can be converted into the DC link voltage using this DC-DC converter. And a wind generator produces a AC output which can be rectified using this rectifier, and that rectified voltage is converted into the DC link voltage using this DC-DC converter. Because in renewable energy system, this DC link voltage is normally maintained constant. So the function of DC-DC converter here is to maintain this DC link voltage. So irrespective of the changes in the input voltage, it will maintain the output voltage constant. And here this DC-DC converter acts as a charger circuit for this battery, because battery has a DC voltage and this DC link is also DC. So this is, you can put a DC-DC converter to charge the battery. And you can find many applications for DC-DC converter in electric vehicles also. Now let us see what is a chopper. So chopper is also a static device which converts a fixed DC voltage to a variable DC voltage. So now we know both chopper and DC-DC converter are same, except that when you use thyristors, we call that as chopper, because in earlier days we were using thyristors and we call it as chopper. The problem with thyristor is that we know that when we apply a gate pulse, thyristor will be turned on, but turn off process is not in our hands. It is controlled by the circuit. So when you have a AC supply as in a rectifier, it gets turned off automatically or naturally due to the reversal of supply voltage. But in case of a DC input, commutation or turning off of the thyristor is a big issue. So you have to add an extra circuit called forced commutation circuit to turn off the thyristor, and we call that process as forced commutation. So extra circuit is required. So nowadays we are using DC-DC converter where self-commutated devices are used. What is self-commutated devices? Like BJT, MOSFET and IGBT. So if you give this is BJT, if you give a gate pulse, it will get turned on, and if you remove the gate pulse, it will get turned off. So these are called self-commutated devices. So today we are using only DC-DC converters with BJT, MOSFET and IGBT because they can be used at very high frequency applications. But the basics lies with chopper. So we will study first chopper, understand the basic behind chopper, and then we will go to DC-DC converter. So what is a chopper? What do you mean by this word chopper? You might have seen this one, vegetable cutter or chopper. So what it does, it will cut the vegetable into small pieces. What is this? This is a chopping board. What do you mean by that? You are cutting the vegetables into small pieces. So this board, chopping board, helps to cut the vegetables into small pieces. So chopping means you are cutting the large one into small pieces. Similarly, in power electronics, if you have a waveform and if you cut the waveform or you chop the waveform, that circuit is called a chopper. This is the basic chopper circuit. Plus minus indicates this is a DC supply which is connected to the load R through a switch CH. This switch is basically a thyristor. Since it is a thyristor connected to the DC circuit, only you have to go for forced commutation. I have not shown the commutation circuit here. Now Vs represents the DC input voltage. When the switch is on, output voltage is equal to supply voltage. So this is on period where output voltage is equal to supply voltage. When I turn off this switch, output voltage is 0. Again when I turn on, it is Vs and again it becomes 0. So in chopper circuit, it is chopping the waveform. This is supply waveform which is continuous. So output is a chopped wave. And this red line indicates the average output voltage. And this T represents the time period or switching frequency. T is equal to 1 by F. Let us see the basic chopper's principle of operation. So supply voltage is here, V0. So when the switch is on, output voltage is equal to supply voltage, and when the switch is off, output voltage is 0. So total time period T is equal to T on plus T off. And I can write V0 is equal to Vs into, what is V0? This is average value. I am finding the average value. V0 is equal to Vs into T on period plus 0 into T off period divided by total time T. So since this part is 0, you leave this one. So V0 equal to Vs into T on by T. But T on by T is called alpha or duty cycle. That is T on by T. T on is the on time of the switch divided by total time period. That is called duty cycle, which is represented by alpha. So alpha into Vs. So alpha value varies between 0 to 1. Next is the control techniques, or how we are able to control the output voltage. We have seen that V0 is directly proportional to alpha into Vs. Alpha is nothing but T on by T. That is, if we change the time period or if we control the time period, we can control the output voltage. So there are two methods. One is called time ratio control. The other one is called current limit control. So in time ratio control, we are controlling the time or the frequency. In current limit control, we will be controlling the current between two limits. So in time ratio control, you have two methods, constant frequency method or variable frequency method. In constant frequency system, the chopping frequency is kept constant. What is chopping frequency? That is, the total time period is kept constant. So if you see these two waveforms, so this is V0, you have on period, off period, on period, off period. Okay, and T, total time period, is equal to on plus off period. Another one, you see the second waveform. Here also you have on period and off period, and total time period T is there. So in both the cases, total time period T is constant or same. So the chopping frequency is kept constant here. What we are doing is we are changing the on time. So if you change the on time, off time will also change because T is constant. This method is also called pulse width modulation technique because you are able to vary the width of the pulse. You see the pulse here, the width of the pulse has increased here. So this method is called pulse width modulation technique, and this is the technique usually adapted in power electronics, most preferred technique for power electronics. In variable frequency system, you see the waveform here, as the name suggests, variable frequency. Here the chopping frequency is varied, T is varied. So here the time period is here till here, whereas in the second waveform it is still here. So we are varying the frequency, but you will either keep the on period constant or off period constant. So here I have kept T on constant. T on is same in both the cases, but off period will be different, so that T will be different. So either you can keep T on constant or T off constant. This method is called frequency modulation technique because you are changing the time period or the frequency. So it is called frequency modulation technique, but this method has some disadvantages, like filter design is difficult because frequency is keep on changing, so filter design will be difficult. And another problem is it may interfere with the communication lines because frequency is involved, so it may cause interference. The other method is called the current limit control method. So in this case, output waveform is same, on period, off period, total time period. So during on period, current will increase, during off period, current will decrease. So in this method, how the switch is turned on and off is mainly based on the current value. So if the current reaches some minimum value, switch will be turned on here. So when the current reaches I minimum, switch will be turned on, and when the current reaches the maximum value, switch will be turned off. Again when it reaches the minimum value, it will be turned on. So based on this current limits, it is turned on and off. So it is called current limit control. This technique is mostly used in drives. Next we will see about the classification of choppers. There are two choppers. One is the step down chopper. Step down means output voltage is less than the input voltage. So this is a step down chopper. You give a fixed DC input. Say I am giving 100 volts. So I may get some 25 volts. Another one is step up chopper where the output voltage will be greater than Vs. So if I give the same 100 volts, I may get some 150 volts. So then we call it as a step up chopper. This is a circuit for step down chopper. Already we have seen the basic chopper in which the supply voltage is connected to the load directly through a switch. The problem with the basic circuit is that when the switch is in off condition, the current becomes discontinuous or the current becomes zero, so the output will be discontinuous. So that here we are providing an inductor and an alternate path for the current can be provided by using a freewheeling diode. So if you see this, when the switch is on, the current flows through the switch, inductance, load. Okay. So this is the circuit. So inductance stores the energy during this period and output voltage V0 is equal to Vs. And when the switch is off, you remove the switch, the inductor has some energy. So it supplies the load through this one or the current freewheels through this one. But since diode is connected across this combination, output voltage will be 0 because diode is a short, so output voltage is 0. Derive the expression for the output voltage. So this waveform already we have drawn, and if you see the output current waveform, during the turn on period it continues to rise, and then when the switch is turned off it starts to decrease, and again when the switch is turned on it begins to rise. So when the switch is on, V0 equal to Vs, switch is off, V0 equal to 0. So this we have already derived in basic chopper. V0 is equal to Vs into T on plus 0 into T of period divided by total time period T. So V0 equal to alpha Vs, where alpha is called the duty cycle, which ranges from 0 to 1. So you can see that when alpha equal to 0, output voltage is 0. When alpha is 1, V0 equal to Vs. It means that output voltage can be only less than the supply voltage. So it is called a step down chopper. Next we will see about step up chopper. What do you mean by step up? Your average output voltage, if it is greater than the supply voltage, we call it as a step up chopper. So for that you need a large inductance in series with a source. So to achieve step up operation you need a large inductance in series with the source. So here switch will be connected here this side and diode here. Let us see the modes of operation. So when the switch is on, so this is the switch. When a switch is on, the inductance stores the energy and we can write Vs is equal to VL. When the switch is off, if I remove this switch, the inductor current will always flow in the same direction, because the property of the inductance is that it will not allow the current to reverse immediately. So initially it was flowing in this direction, so it will allow the current to flow in the same direction only. So current flows in this direction. So now if you write the equation, Vs plus VL is equal to V0, output voltage. So we can find that V0 is greater than Vs. Let us write the energy equation. So during the switch on condition, we know VL is equal to Vs, and off condition VL is equal to V0 minus Vs, that we have derived. Now what is the energy input to the inductance from the source side? So what is the energy? Power into time. So power is V into I. So multiply by that time period. For on time, multiply by T on. For off period, multiply by T off. And what is VL? VL equal to Vs. So what is I average? I1 plus I2 divided by 2. So there are two limits, I1 and I2. So you find the average of this, means add those two and divide by 2. You will get the average value into T on. And similarly for here also do the same thing. Now we are assuming that it is a lossless system. What do you mean by loss system? Whatever is energy is stored during the on period will be released during the off period. So you can equate this one to this one, that is on period energy is equal to off period energy. So you equate these two, common terms get cancelled. So Vs into T on equal to V0 minus Vs into T off. So you simplify this one, you will get V0 is equal to Vs divided by 1 minus alpha, where alpha is T on by T. So this is the output voltage expression for a step up chopper. So this is important. For step down chopper, V0 is equal to alpha Vs, whereas for step up chopper it is Vs divided by 1 minus alpha. The points to remember here are: chopper is a static device which converts a fixed DC to variable DC. It can be considered as a DC equivalent of an AC transformer. Duty cycle alpha is written as T on by T. There are two types of chopper, step down and step up chopper. And in choppers, thyristors are used. Since chopper is a DC circuit, you have to use post commutation circuit. And the pulse width modulation technique is the most preferred technique for power converters. And if you need this study material, you can go through this website. And if you like the video, do subscribe to our Read Electric Vehicle channel. These are the references. Thank you.